My name is Brendan Vermiere. I'm a clinical advisor for FDN. The topic for today is gut microbial carbohydrate metabolism contributes to insulin resistance. This study is another example of how recent research is helping identify gut bacteria that might help improve insulin resistance and protect against development of obesity and type 2 diabetes. Dr. Gonshor, thank you for always joining us on this amazing show, Science Matters.
Well, thank you, Brendan. It's a pleasure to have you. And let's jump right into it. I always say that in each of these sessions, we take a deep dive into recent research. And it's important to remember that we're really looking at recent research. Doesn't make the earlier research worse, but we're really trying to stay up to date and try to bring to light objective scientific evidence on whatever the topic at hand happens to be. So today, yes, we're going to take a much closer look at gut microbial carbohydrate metabolism and how that contributes to insulin resistance. Really fascinating. This study, like other recent research, is now clearly showing that there are gut bacteria that are associated with insulin resistance and reversely insulin sensitivity, and that they show a distinct pattern, these bacteria, of carbohydrate metabolism. So, Brendan, let's look at the actual evidence because science matters.
After our last broadcast, which was titled Dose of Jogging and Long-Term Mortality, there were some questions that came into our attention. One of the questions is part of a long-standing debate about cardio versus high-intensity interval training, specifically which regimen actually provides a better workout or more health benefits. Your thoughts, Dr. Gonshor?
This is a very interesting one, and we get a lot of comments about this. High intensity interval training, and I know there are going to be people listening here who do a lot of that, typically includes an intense work phase, and that can last for a few seconds. It can last for several minutes. Normally, as you know, some people will do 1 to 2 or 5 minutes, and then they do 30 minutes of something else. There are a whole number of different variations. And usually when they're doing that HIIT, it's being performed at a very high level, about 80 to 90 or 95% of a person's maximum heart rate. Now, this is then followed by a recovery phase, and that can last as long as the intense work phase, but quite often much longer and at a lower intensity, of course. So that could be about 50% of their maximum heart rate. Now, many fitness trainers consider that cardio, for example, if you're running, right, on a treadmill at that high intensity, is the least efficient form of exercise because it's not metabolic, meaning that it doesn't really cause the body to continue to burn calories post-workout. That's what you really would like. So in clinical terms, that high intensity workout isn't really better than traditional cardio exercise, also known, by the way, as moderate intensity training. MICT, you'll see that acronym. Well, it's often noted that to see any gains over time, the air quote, better exercise regime is arguably the one that's consistent and sustainable, right? You guys can tell me everything you do. At the end of the day, the question is, hey, are you doing it every day? Are you doing it every second day? Because if you're not, it doesn't matter. So is it sustainable? So the conventional wisdom is that one isn't necessarily better than the other. The main difference between the two is in the time demand and the preference of that individual. Finding something you enjoy and that you're going to continue to do is more important than forcing oneself to do an exercise that may have slightly different benefits. So, for example, a standard exercise recommendation to maintain overall cardiovascular health is to do what? To accumulate about 150 minutes, 2.5 hours of moderate intensity activity per week. Not terrible. You can do that. If the goal is weight loss, it requires a caloric deficit of 3,500 calories just to lose 1 pound. So this would be best accomplished with both diet and exercise. However, if one is trying to lose weight by exercise alone, wait a minute. Now you've got to accumulate 350 to 450 minutes. That's 6 to 7 hours a week of cardiovascular exercise, if that's the only way you want to lose weight. And frankly, that is a very, very tall order for most people. And you know what happens when you look at the studies? They don't continue doing it. So what's the point? So really, at the end of the day, find something that's going to be sustainable for you, not for someone else, for you. And if you can get that couple of hours of exercise with your healthy diet, guess what? That's the best way to approach it.
That was an excellent answer, Dr. Gonshor. And having over 14 years of experience as a certified personal trainer and nutritionist myself, I very much agree with your statement of they have to love it. If they don't love it, they're not going to do it regularly. And ultimately, compliance is what drives outcomes. We can achieve excess post-oxygen consumption through a variety of mechanisms, but ultimately, whatever you love that gets the body moving. And thank you all so much for submitting your questions. Be sure to keep those questions coming because they're very important to all of us as we learn together. So now, Dr. Gonshor, let's go ahead and jump into today's study about gut microbial carbohydrate metabolism contributing to insulin resistance.
Well, thank you very much for that. And I didn't know that you were a trainer. Thank you so much for corroborating that. It's very important. Does everybody see this?
Yeah, looks great.
Okay, so let's take a look at gut microbial carbohydrate metabolism and how that contributes to insulin resistance. And here's the paper. It's actually quite a detailed paper for those who are going to look at it, because remember, we put these papers up on the site and you can actually look and study it. It is very, very detailed. And what they're really talking about here is that there are gut bacteria that are associated with insulin resistance. And we can go into what insulin resistance is in a minute. And of course, insulin sensitivity as well. And they show a distinctive pattern of carbohydrate metabolism. And that demonstrates that insulin sensitivity associated bacteria, those that are associated with some form of insulin sensitivity, are actually very much involved in insulin resistance. So what do we need to know? Well, what is insulin resistance? Well, IR, which we call it, or insulin resistance, develops when cells in the muscles or in fat or in liver, in fact, in most cells of the body, don't respond to insulin. So the cells, because they don't respond to insulin, they're not using the glucose. If that glucose isn't being used, it starts to build up in the blood. And that's when you start getting people with very high blood sugar levels, et cetera, et cetera. It can be temporary or it can be chronic. And in some cases, and people will say even many cases, if you look at it properly, is treatable. And so if cells become too resistant to insulin, as I said, it can lead to that elevated blood glucose, otherwise known as hyperglycemia, which over time, and this is important, will lead to prediabetes or frank type 2 diabetes, which you don't want. You don't want to be there. And insulin resistance is one of the first things that you begin to see as part of what we call metabolic syndrome. It's a grouping of different problems of which insulin resistance is an important piece, and they're associated with these wonderful things: obesity, cardiovascular disease, non-alcoholic fatty liver disease, and polycystic ovarian system, PCOS. So it's not good if you're in that situation. So what role do bacteria play in insulin resistance? And remember, this is all background. We haven't touched the study yet, but you need to understand this context. The gut microbiome, we know, breaks down the carbohydrates from food. We know that. So that's part of where it creates a link between this process of the breakdown of carbohydrates and obesity and prediabetes. So until recently, this link had remained unclear. We understood it was going on, but we didn't quite know how it was happening. And it was unclear because of this vast diversity of bacteria in the gut microbiome. There are about 15 trillion bacteria. And so we didn't really know how this diversity was working. And we had a tremendous lack of metabolic data to which we could refer back to. So this present study tried to look at this in a concerted way for the first time. And what they did, and it's gutsy, I have to tell you, is a comprehensive multi-omics approach. When I was studying physiology for my PhD, omics didn't even exist. But now we talk in omics. What is it? Multi-omics, integrative omics, pan-omics. What it really is doing biological analysis in which the data are sets of multiple ohms. What does that mean? Well, you could be looking at different types of genomes, proteomes, transcriptomes, the epigenome, very important, metabolome, and the microbiome. And so they looked at all of this, and they identified gut bacteria that helped reduce insulin resistance, and in that way, protect against obesity and type 2 diabetes. Think about that statement. That's quite remarkable. And the methods that they used, well, they examined the metabolites that were coming out in the feces of more than 300 adults with regular checkups. Then they compared this metabolome, looking at the metabolites in the feces, with the insulin resistance levels of these same people. So they were able to start relating the insulin resistance to one of the ohms, in this case, the metabolome. And that led to the discovery of certain types of bacteria that might help reduce insulin resistance. So what are the findings? Well, the higher insulin resistance situations were associated with excessive carbohydrates in the fecal matter, especially monosaccharides like glucose, fructose, galactose, mannose. So remember, for those people who had these excess carbohydrates, they were showing higher levels of insulin resistance. So the author said the increased insulin resistance was associated with microbial carbohydrate metabolism and some host inflammatory cytokines. So we started looking at this. Okay, carbohydrate metabolism controlled by these bacteria, and these people have higher insulin resistance. So people with that higher insulin resistance contained more bacteria from a taxonomic order. That's a very large grouping of bacterial families, in this case, the Lactospiraceae. And there were a whole number of bacterial families within that large taxonomic order. Some of them were the Dorea products, some were the Blaudia products. Those are bacterial groups. And all of these groups were associated with excess fecal carbohydrates. So when you had a lot of these bacteria in the feces, you had an accumulation of a lot of carbohydrates. Insulin resistance and monosaccharide levels, which are part of the carbohydrates, were lower in participants whose guts had more Bacteroides type bacteria. In particular, Alliceps indistinctus. This is a particular bacterial group. Very interesting. And they looked at this in humans and in mice. And in obese mice, they looked at how treatment with different bacteria affected the blood sugar levels of these obese mice. And when they did, Alliceps indistinctus, we'll call it AL, lowered blood sugar and reduced both insulin resistance and the amount of carbohydrates available to the mice. So these results were quite compatible with the findings that they had from human patients. So their conclusion there was bacteria that are associated with some form of insulin sensitivity will decrease the tendency of the host gut toward the creation of IR. In other words, if you have more of this bacteria, Allistapes, guess what? You're going to have less chance of developing insulin resistance. So what are the implications for diagnosis, for treatment? Well, the authors say because of its association with IR, the presence of the gut lacno spirochetes type of bacterial groups could be a good biomarker for pre-diabetes. That in and of itself would be very valuable. And likewise, you may be able to treat with probiotics that contain this particular type of bacterial family, and that might improve glucose intolerance in those with pre-diabetes. Very fascinating. Now remember, there's a note of caution. Over-the-counter probiotics today do not contain the bacteria that are identified in this study, and I'll comment on that a little bit later. If they do become available, and I would suspect they will soon, then the authors do have a note of caution. These findings need to be verified in human clinical trials before they're recommended for any probiotic as a treatment for insulin resistance. So the key takeaways we can see in this schematic. What did they do? Multiomics, metagenome, metabolome, transcriptome, et cetera, et cetera. So they were able to determine the clinical phenotype of that host. And then they were able to look at the human findings. For a microbiome that is insulin sensitive, what do you have? Higher levels of allistapes, lower levels of monosaccharide in the feces. For the microbiome of those who are insulin resistant, you have an increased level of the Doria and Blauschia groups, not of the allistapes. What do you have in that case? Higher levels of the carbohydrate, the monosaccharide. So unlike the insulin-sensitive microbiome, which has less inflammation, less BMI, in other words, less obese, these are people who have higher insulin sensitivity. That's where you want to be. You don't want to be with the insulin resistance group, where they are higher inflammation of the gut, higher BMI, in other words, tending towards obesity, and they have less insulin sensitivity. So in the experimental finding was the same thing. Allistapes, if you have a lot of that, less carbohydrate in the feces, guess what? These mice have less body mass and less accumulation of lipid. In other words, they are insulin sensitive. Lovely study, actually. And that's it for today's Science Matters.
Thank you so much, Dr. Gonshor. I get really excited anytime we're talking about the microbiome. I often refer to it as the garden of life. You know, the more that microbiome research expands, the more we see the implications on nearly every facet of our health in general.
Absolutely.
Absolutely. And for those of you watching, please be sure to subscribe, like, and share if you enjoyed this content. Submit your questions, your comments, and suggested topics at www.fdntraining.com/Science Matters. And be sure to grab a copy of the studies to read along with us at www.fdntraining.com/studies. And be sure to join us again in 2 weeks on March 6th, when we'll talk about molecular jackhammers destroy cancer cells with vibration, because
Go ahead.
science matters.